Okay, so good afternoon. Can you hear me?
Yes, sir.
Okay, thank you. So, in earlier classes, we have seen that in an atom, each and every energy level, there is a possibility that maximum 2n square number of electron can occupy. That is, this 2n square number of electrons are degenerate. However, Bohr's theory cannot separate this 2n square number of electrons lying in a specific energy level. This is because electrons are identical particle, and according to Bohr's theory, energy was totally dependent on n. However, in later stages, we have seen consideration of relativistic effect as well as spin-orbital interactions helps us to separate out or remove the degeneracy at least partially. However, still to differentiate each and every state of the electrons in a particular energy levels, we need to take help from the external perturbations, because unless and you are applying any external perturbations in the form of magnetic field or electric field, although effective electric field yet we didn't study it, in later classes we will see. But applying magnetic field, what we can have, we can separate each and every this 2n square number of electrons, and in that case we have seen that energy is characterized by mj, and for a particular value of j, mj can energy is characterized by j, total angular momentum quantum number, and for a particular value of j, it has twice j plus 1 values. And this was required because according to Pauli's exclusion principle, no two electrons can have same state, that is same set of n, l, ml and ms. So obviously these states are different, but Bohr's theory, and unless you apply external perturbations, it was not possible to identify these individual states. So for single atom, we have checked, we have seen these things. Okay. So today we'll proceed further to see the cases for multi-electron system. Multi-electron system means atoms having more than one optically active electrons. You remember that in case of alkali atom, these atoms are having more than one electrons, but only one optically active electron. So multi-electron atom means more than one optically active electrons, because we are studying atomic spectroscopy, and atomic spectroscopy deals mainly with the properties of the atom due to optically active electrons, that is outermost electrons. Okay, so we'll see this. Okay, so before going this, let's see some terminology. তোমরা সবাই তো এই বই পেয়েছো, এটা ছিল তোমার রাজকুমারের বই. Someone of you have given me this soft copy that I have shared in the screen. I think you can see, you can open also in your computer or whatever it may be. Is chapter 9. Okay. So state of an atom. We have heard this word several times. So state of an atom means condition of the motion of all the electrons within the atomic systems, and that means you are identifying the states of all the individual electrons in a particular atoms, and these are characterized by mainly identifying or indicating the four quantum number L, N, L, ML, and MS. So if you are say uh, dealing with, say, sodium atom, then sodium atom you have 11 electrons. So if you want to comments on the states of your sodium atom, what you have to do, you have to say the state, that is four quantum number, values of four quantum number for each and every electrons, and this state should be unique according to Pauli's exclusion principle. So this is your state. Then energy level. Energy level means a collection of states, because in Bohr's theory, and this is characterized by quantum number n, and already we have seen n is equal to 1, 2, 3 like this, and energy for a particular set of or more than one electrons lying in an energy level is characterized by n, and for a particular energy level if is characterized by quantum number n, and maximum 2n square number of electron can occupy in a particular energy level. Since 2n square number of electrons in an energy level, that means 2n square number of independent states. That's why energy level is a collection of states, and the level with lowest energy level is your ground level or ground state. Sublevel, we have seen that if you apply external perturbation, then level splits. Level split means degeneracy removed. That means you are separating the state of your electrons. So if you apply external perturbation, this splitting of energy level, you will get sublevels. Okay, and we have seen in case of Zeeman effect, the sublevels are characterized by mj, and for a particular value of j, mj hoche twice j plus 1 values. Then term term is a collection of levels, and it's characterized by angular momentum and multiplicity. Multiplicity means spin, and this is characterized by twice s plus 1. And angular momentum means capital L. If one electron, then this capital L and small l same. Otherwise, for more than one electron, it's always capital L, because it's a resultant of interaction between small l's. So we will see how these interactions happen in later parts. So it's characterized by your spin, multiplicity, that is depending on spin twice s plus 1, and then L. For example, 3D term, it can have levels 3D3, 3D2, 3D1, etc. So 3D term is consists of 3 levels: 3D3, 3D2, and 3D1. Then configuration. Configuration means specification of the quantum number n and l for all of your electrons. Already তোমরা দেখছো যেমন সে সোডিয়াম 1s2, 2s2, 2p6, 3s1. So we say this is the configuration. That means 1s2, that means you are commenting 1 means n is equal to 1, s means l is equal to 0. That means 2 electrons corresponds to n is equal to 1 and s is equal to 0. Then 2s2, that means another 2 electron corresponds to n is equal to 2 and s is equal to 0. 2p6, that means 6 electrons corresponds to l is equal to 1 or n is equal to 2. So identification or specification of n and l for all the electrons in an atom, this is your configurations. Then equivalent orbitals for orbitals having same n and l, we say the electrons are equivalent. For example, 1s2, these 2 electrons are equivalent because they are having same value of n and same value of l. Similarly, 2p2, 2p3, 2p2 means 2 electrons having same n is equal to 2, l is equal to 1. 2p3, that means 3 electrons, 3 equivalent electrons, because all these 3 electrons have same n and l values. So this is your equivalent orbitals. Then statistical weight. That means occupancy. That is twice J plus 1. Then component. Component means transition between two sublevels is called component. You are applying, for example, in case of Zeeman effect, if you are observing, say, in case of sodium D line, because according to spin orbit direction, you are having two lines, because these are transition from say P 3/2 to S half and P half to S half. But if you apply Zeeman effect, then your P 3/2 level splits into another twice J plus 1. That means another 4 sublevels. Then these sublevels transition from these sublevels to lower sublevels. This is your component. Then line. Line means transition between two levels. Two levels means, for example, say n is equal to 2 to n is equal to 1. N is equal to 4 to n is equal to 2, like this. Multiplet means a collection of transitions between two terms is called multiplet. Two terms, because one term consists of more than one levels. So if you are studying a transition between two term, means it's a number of lines. So this is called multiplets. Okay. Then resonance line. Resonance lines means if you have more than one transitions between two levels, then the lowest frequency, that is means the transition to ground state from the next higher energy stage. It's lowest energy, that means lowest frequency. These are called resonance line. Okay. So is it clear till now? You can see in the book also. Boyo dekhte paro. Okay. Shubhajyoti?
Yes, sir.
Okay.
Yes, sir.
Okay. Okay. So let's. So these are terminologies. Some terminology whilst we are commenting or studying spectral feature. So this terminology will be used very often. For example, already we have used a lot of time this state, energy levels, configuration, etc. Okay. Now, say normally the energy of the electrons is mainly related with the Hamiltonian of the atom, and this was mainly related with the kinetic energy and potential energy. And so far we were studying for the case having only one optically active electrons. So the Hamiltonian was P square by twice m and minus z square by r. It was very simple because kinetic energy, but when you have more than one optically active electrons, then kinetic energy, potential energy, everything will be changed. This is because, for example, if in a classroom or a single person is moving in a whole empty room, and if you take another case where, say, more than one person, say 2 person is moving, the same size, similar configuration wala room monte, then what will happen? You will see in the second case, there is a probability these 2 person may collide. So these 2 person should be always careful. That means their motion will be modified, changed. Okay. So similarly here also, if you have only one optically active electrons and another case where more than one optically active electron, then obviously motion will be modified. So this will affect the Hamiltonian, and accordingly energy then spectroscopic term, transition, everything. Okay. So let's see how the Hamiltonian of an atom having more than one electrons look like. Okay. So let us consider a case. Okay. Okay. So let us consider a case where an atom having nucleus of charge, say, plus Ze, and there exist capital N number of electrons surrounded the nucleus, and may be equal to Z or less. Okay. In this case, in this atom, there will be a completely filled up core, then some electrons surrounding the systems. Okay, so we will consider only we will mainly neglect the effect of core in this case. Say, let us consider all these n electrons are optically active. Okay, so in that case, what will happen if you have, say, 5 electrons? Then you have, for kinetic energy, what you have to do, you have to calculate each and every kinetic energy for each and every electrons, then sum to have the total kinetic energy. Here also, you will have in the Hamiltonian a term which corresponds to the total kinetic energy of all the electrons, and this is equal to, you will see, summation I is equal to 1 to n pi square by twice m. That means kinetic energy for all n electrons. Okay, where pi is the momentum of the ith electrons, or m is the mass. Similarly, the electrostatic energy or potential energy, this regarding the unit system. So we will not, we are not concerned about this part. Okay, so this is depending on the unit systems. Okay, so don't worry about these issues. Okay, so what will happen? You have to calculate the potential energy for all of your n electrons. So say if Ri is the distance of ith electrons from the nucleus, then the interaction between that electrons and the nucleus will be this Z square by minus Z square by Ri. Okay, where Ri is the distance of the ith electrons. So you are adding all the potential energy or electrostatic interaction energy. Okay, so this is actually more or less, in earlier case also it is zero, but in that case only one electron, so there is no requirement of addition. Okay, so this is, you can say, total potential energy, total kinetic energy. Okay, so this term is extra because now you have more than one electrons. So there is a possibility, since electrons are charged, then electrostatic interactions will occur between the electrons itself. So this is called mutual or residual electrostatic interaction energy, because if you have n number of electrons, then each and every electrons will interact with remaining n minus 1 number of electrons. So if you want to calculate for first electron, then you have to calculate interaction between first one, second one, first one, third one, first one, dot dot, say n minus 1. Similarly, for second one, interaction between second one with first one, second one with third one, like this. So if you will have a term like this, you will see here this ith electron will interact for all the remaining electrons. So it's J is equal to 1 to n minus 1, that is excluding these electrons which you are calculating. Okay, so এটার পরে আবার নেক্সট ওয়ান, এভাবে করে করে তোমাকে টোটাল ক্যালকুলেশন করলে এরকম টার্ম দাঁড়াবে যে j is equal to 1 to n minus 1 e square by rij, where rij is the distance between ith electron and jth electron, because you are here calculating the interaction between ith electron and jth. Then ith, jth case is another one like this. Okay. And charge E for all, that's why E into E is square. So this term is due to interaction between electrons, each and every electron with remaining all electrons. Okay, so this is called mutual residual electrostatic energy of the electron. So in your Hamiltonian, in addition to kinetic energy and potential energy, you will have this term also. Then you will have another term. This is called spin correlation energy. This is because we know that parallel spins repel each other and antiparallel spin attract each other. This is because spin is related with magnetic moments. So field, so direction, if direction is opposite, so there will be attraction, otherwise repulsion. So this will also affect the energy or motion. So you have to include this effect also in your Hamiltonian. Okay. Then we have spin orbit in magnetic interaction. That is spin orbit interactions. Already we have seen this one, L dot S. Okay. So all these issues you have to take care of while you are analyzing the Hamiltonian of your atom having more than one, that is capital N number of electrons. Okay. So most of the cases, okay, in case of atomic spectroscopy, we consider central field approximations. And in central field approximation, each electron is considered as if it is moving independently in a separately symmetrical net potential that describes the average of its total Coulombian interactions within the nucleus surrounding all electrons. So in earlier class also I have we talked in this issue. So this is an approximation to analyze the systems, the complex systems, because it is made in a simpler way. So in that case, what happened while you are calculating or analyzing the effect of interaction for more than one electron, then you consider one electron is interacting with your nucleus, where the system will consist of an average Coulomb potential. Average of what? Average of all interactions. Okay, all interaction, that is interaction of all electrons with the nucleus. For example, if you have say 10 electrons, then you have nucleus. So all these 10 electrons will interact with your nucleus. So if you want to analyze, say for a electron, then what you have to consider according to this approximation, that total interaction, that means interaction between nucleus and the remaining all 9 electrons are same. So if there is total say n unit of interactions, then divided by 9, this is average Coulombian potential. So in under this potential, you will analyze the motion of your selected electrons. So this is central field approximation. Under these approximations, mainly first 3 terms, that is kinetic energy, then potential energy, then residual electrostatic interaction energy. These 3 terms mainly contribute to the motion or spectral feature of your systems. So you have to have some kind of mechanism so that you can have idea how the movements of individual electrons get modified when they interact with each other. That means in earlier discussions, moments, that is for each and every electrons, there was one part orbital angular momentum, then spin angular momentums. But now, since we have more than one electrons, so due to interactions, their momentum is modified. So we have to have some kind of mechanism so that we can have the resultant movements, maybe orbital, maybe spin-orbital interaction, whatever may be. So we need some kind of mechanism. This is called coupling schemes. And in ageo tumra egulu porcho hoyto LS, there are two main coupling scheme. One is LS coupling scheme and another is JJ coupling scheme. In case of LS coupling scheme, this is mainly it's this kind of coupling is mainly theoretical theory. You can calculate the resultant moments using this kind of theory. Okay. In real cases, you have to measure through experiments. So this LS coupling scheme is mainly based on the name of two scientists, Russell and Saunders, and this coupling scheme is valid for lighter atoms. And in that, lighter atom means where electrostatic interaction effect term, this term 3, that is E square by Rij, and the spin-spin correlation effect, spin-spin correlation effect, that is due to interaction between spin magnetic moment, that is attraction between anti-parallel spin and repulsion between parallel spin. These two terms is mainly dominating rather than your spin-orbital interactions. So what will happen when you are trying to calculate the resultant moments, orbital or spin? What you have to there exists spin-orbital interaction also. Since because in earlier case also single electron atom under the exchange spin-orbital interaction karone energy level split হয়ে যাচ্ছিল L plus S and L minus S level. So in according to LS coupling schemes, যে তোমার কি করতে হইব resultant moments calculate করতে গেলে প্রথমে আমাদের দেখতে হইব যে interaction between individuals L's, then interaction between individual spins of more than one electrons, then resultant spin moments and resultants these orbital moments, they will interact with each other. Okay. And JJ coupling, what will happen here? Spin-orbital interaction dominates. So for each and every electrons, this L and S, that is orbital angular momentum and spin angular momentum quantum number, they will interact fast. Then and results a total angular momentum quantum number or momentum for each and every electron, then all J will interact. So you have to calculate in this way. So let us see first the LS coupling scheme. So in case of LS coupling scheme, the main modification or perturbation is due to spin-spin correlation, that is interaction for more than one spin of more than one electrons. Then residual electrostatic interactions, that means electrostatic interactions due to more than one electrons, then spin-orbital interactions. So there exist three interactions. Okay. So in the first case, as a result of spin correlation effect, that is interaction between spins of more than one electrons, the individual spin angular momentum of vectors of the optically active electrons are strongly interact with each other. Okay, and they will results a new spin angular momentum quantum number, capital S, jar magnitude of the order of root over s into s plus 1 h cut, and this capital S is a constant of motion in case of more than one optically active electrons. A S হচ্ছে resultant of interactions of all smallest of all of your optically active electrons. Okay, and the quantum number capital S can have values S is equal to S plus S1 plus S2 plus S3, say dot S1 plus S2 plus S3 minimum. That means if you have two systems, say S1 S2, then your capital S will be S1 plus S2, then S1 plus S2 minus 1, then S1 plus S2 minus 2 dot S1 minus S2. Okay, so if you have more 3, then S1 plus S2 plus S3, then S1 plus S2 plus S3 minus 1, S1 plus S2 plus S3 minus 2 dot up to minimum. Okay, so we will see with some example, then it will be clear. Okay, and another important issue, the state, then in that case, due to interaction between smallest of more than one electrons, you will have different capital S values. Okay, in that case, the state having highest capital S being the lowest energy. So you remember the highest S being the lowest energy. Okay. So let us take example. For example, if you have only one electron, then your small s is equal to half, your capital S is equal to also half. Okay, because there is no interactions. Then your multiplicity twice s plus 1 is equal to 2. So this is a doublet level. If you have two electrons, that is S1 is equal to half, S2, remember, always S is equal to half for one electrons. MS will be half and minus half. This is direction. But spin is always half. Okay, so S1 is equal to half, S2 is also half. Then your S is equal to S1 plus S2, that is half plus half, 1. Then S1 plus S2, S1 minus S2, half minus half, 0. In between, 1 minus 1, nothing, 0. So only 1 and 0. So for two systems, two electron system, we have S is equal to 0 and 1. And this is due to spin-spin correlation effect. Okay. If you have 3 electrons, then again, S1 is equal to half, S2 is equal to half, S3 is equal to half. So if you consider interaction between S1 and S2 first, then interaction between S3 and the resultant S values. Okay, so S1 and S2 interaction will give you 0 and 1. Then S3, that is half, will interact with 0, that is half plus 0, half minus 0, 1 and half, then half with 1. So half plus 1, 3 by 2, half minus 1, that means 1 minus half, half. In between, minus nothing exists. So there will be 3 values, half, half, 3 by 2. 2 sets of doublets, that is twice s plus 1, this is 2, again 2, here this is twice s plus 1, 4, that means quadrats. So here you can see this one, the result interactions of spins, individual spins of 2 electrons will result as singlet state S is equal to 0, triplet state S is equal to 1. For 2 no, this is for 2 electrons. Okay, for 1, no interactions, only half. So this is for 2 electron system, 3 electron systems, doublet S is equal to half, again S is equal to half, and S is equal to 3 by 2 quadrat. Similarly, for 4 electrons. 4 electrons, what you have to do? First, consider interaction between 2, that is 0 and 1. Then half with 0, half with 1, then again half with the resultant ones. Okay. So you will have this kind of sets. In general, for n electrons, the possible values of S are S is equal to 0, 1, comma 2, dot, dot, capital N by 2 for even n. And S is equal to half, 3 by 2, 5 by 2, capital N by 2 for odd n, Okay. Okay. So, আমরা আগে বলেছিলাম যে কি for highest largest value of S will have minimum energy. So to this can be explained physically that we know parallel spin will repel each other and anti-parallel spin will attract with each other. So potential energy is distance dependent, z square by r. So if R is more greater, then energy will be lower. So here spin will be value of spin will be highest when two spins is parallel, because if you add two parallel vector, it will be give you a bigger amplitude than anti-parallel vectors. Okay, so a bigger spin that is parallel, they will repel each other, so distance between these two electrons will be larger. In that case, energy will be lower. So the reverse thing, anti-parallel S will be lower because these are vectors, so anti-parallel vector will result a lower magnitude, so amplitude. Okay, but distance anti-parallel will attract, so distance will be minimum, lower. So energy will be higher. So this is your due to these interactions between spins of more than one electrons, that is spin-spin correlation effect. Then according to LS coupling scheme, what you have to consider, the interaction between L, small l of more than one your orbital electrons, that is optically active electrons, and here also all small l will interact, for optically active electron will interact with each other and results a resultant orbital angular momentum vector, capital L. Here capital L is different than the small l. Okay, this capital L is a resultant of interactions between different or more than one small l. The magnitude is of the order of root over twice L into L plus 1 h cut. Here same, capital L is equal to L plus 1, L plus 2, maximum to minimum. Okay, and difference of the order of 1. Here also the state with largest L having lowest energy. Okay, so you remember this can be explained with one example. Say, consider an atom with circular orbits having 2 electrons. Okay, so in that case, it will be electrons will repel each other because they are charged particles. So it will be a stable system when these 2 electrons are at the opposite ends of the diameter, that is distance is maximum. In that case, energy will be minimum because it's a stable system. And here you see the directions will be according to the tangent of the circle here and here also. So it's same directions. Okay, in that case, so L will be maximum, but energy is minimum. So when you will have capital L value more than 1 due to interaction of different small l's, always remember highest L value will lie lowest. So let us take example, say 2 electrons, one is 3p electrons, another is 3d electrons. 3p electrons means electrons having n is equal to 3, L is equal to p. Similarly, 3d electrons means electrons having n is equal to 3, L is equal to 2. So for these two electrons, you see L1 is equal to 1, L2 is equal to 2. So according to LS coupling scheme, they will interact each other and results L1 plus L2 and L1 minus L2, L1 plus L2 minus 1 minus 2 like this. So L1 plus L2 means 1 plus 2, 3. L1 minus L2 means 1. So L1 plus L2 minus 1, 2. Then minus 1, again 1. So in between this 1 and 3, only one value 2. So capital L have 1, 2, 3. এগুলোকে designate করা হয় S, P, D, F corresponds to L is equal to 0, 1, 2, 3 like this. So 1 corresponds to P states, 2 corresponds to D states, 3 corresponds to F states. Similarly, if more than 2, then first you have to calculate for 2 electrons, then 2p, 3p, 4d. So L1 is equal to 1, L2 is equal to 1 because both are p electrons, then 2. So what you have to do for 1, 1, that means 2 and 0. No, sorry, 2, 1, 0 because 1 plus 1, 2. Then 1 minus 1, 0. So in between 1 plus 1 minus 1, 1. So for these two electrons, 2p electrons, resultant L is equal to 0, 1, 2. Then your remaining L of your D electron, that is 2, will interact with 0. 2 plus 0, 2 minus 0, same value, 2. Then 2 plus 1, 3, 2 minus 1, 1. So 3, 2, 1. Okay, 3, 2, 1. Then your 2, 2 interaction, 2 plus 2, 4, 2 minus 2, 0. So 4, 3, that is 2 plus 2 minus 1, 2 plus 2 minus 2, like this. Then 0, 1, 2, 3, 4. So these are the state. And you have got it using your LS coupling scheme. After that, what will happen? All the resultant capital L and capital S will interact with each other, and they will result a resultant total angular momentum vector capital J, where J is equal to L plus S. So each and every this L value will interact with each and every S value. So you will have several of J values where magnitude is towards J into J plus 1 each cut. আর ক্যালকুলেশন করলে J is equal to L plus S থেকে L minus S. Okay. So this is your LS coupling scheme. Now, if you have any query, you can raise. Else we will proceed. Okay. Okay. শোনা যাচ্ছে তো?
হ্যাঁ স্যার।
Then there is another rule. This is called Londay interval rule. This is we have seen for single electron systems. Already we applied this spinor interactions, but here also if you apply spinor interactions for during LS coupling scheme, that is, if you calculate the interactions between values of all capital L and values of all capital S, that is spinor interaction between your resultant orbital and spin moments, then you will have your fine structure here also. Earlier case it was L plus S and L minus S, only two level doublet system, but here it will be more because you are having several capital L values, several capital S values. Okay. So in earlier cases also we said this is fine structure. Fine structure means splitting of energy levels or splitting of spectral lines. Okay, that in case of Bohr's theory, n for a particular value of n only one line, but consideration of spinor interactions giving you more than one line. Relativity interactions, again another splitting. So these are fine structures. Okay. So in case of LS coupling scheme, this rule help you to have idea about the separation between two consecutive fine structure component, fine structure lines. Okay, so fine structure splitting is mainly governed by L dot S. Now we can write J is equal to L plus S. এখান থেকে L dot S like this. J dot J মানে L square plus 2S. L dot S plus S square. এখান থেকে L dot S is equal to half of the order of this one. Similarly, energy is also depending on L dot S, মানে some constant. There are some fine structure constants. So simply it's written as A by A like this. Then J into J plus 1, L into L plus 1, S into like this. যেখানে এটা ছিল তার amplitude. This is according to your LS coupling scheme. Due to interactions, you will have resultant J, যার amplitude হচ্ছে root over J into J plus 1, মানে J square of the order of like this, L square of the order of this, S square of the order of this. So energy like this, where this A মানে হচ্ছে all constant are being replaced by A. Okay. So now if you have a fine structure system, then separation between two lines is characterized by your J and then J plus 1, because fine structure is dependent on J. Okay, so J and J plus 1, that means if you say L and S is same for your all these fine structure, before and after spin-orbit directions, only separation is due to interaction between L and S, you will have a resultant J. So it's totally dependent on J. So let's see that difference or separation between two J levels. One is J is equal to J, another is equal to J is equal to J plus 1. So what you have to do, you have to put J is equal to J plus 1. আর জের জন্য তো এটা আছেই, দুইটার যদি ডিফারেন্স নাও, you will see EJ plus 1 minus EJ is equal to like this. সেখানে L into L plus 1 আর S into S plus 1 ক্যান্সেল আউট হয়ে যাবে, কারণ দুইটাতে এটা আছে, শুধু জের জায়গাতে একটাতে J into J plus 1 বসানো হয়েছে। So is equal to 2A J into J plus 1. That means energy difference between two fine structure component in case of LS coupling scheme is proportional to the energy of the highest one or highest J value, proportional to the J plus 1, that is larger of the two J values involved. যে দুইটা তুমি ক্যালকুলেট করছো, একটা J একটা J plus 1, তার লার্জারের সঙ্গে প্রপোর্শনাল. This is Londay interval rule. তার মানে কি, Londay interval rule gives you idea about the energy or splitting or separation between two consecutive lines in a multiplane in a fine structure systems. And according to this rule, it says that the separation between two fine structure lines is proportional to the highest J value corresponds to these two lines. So now let us say take one example, say 3p0, 3p1, 3p2. This is a multiplane. So let's see, এবং এটা হচ্ছে L is equal to সবটাতেই 1, ঠিক আছে? So let's see যে এখানে সেপারেশন কিরকম হচ্ছে। So p0 আর p1 according to this rule proportional to 1, তাদের মধ্যে এনার্জি ডিফারেন্স। Similarly p1 and p2 according to Londay interval rule is proportional to 2. So এই দুইটা separation of the order of 1, এটা of the order of 2. So we can say that the separation ratio in this case is 1:2. Similarly here, this is 2:3, because 1 and 2 separation proportional to 2, 2 and 3 separation proportional to 3. So in this system, this is 2:3. Similarly, for other complex system also, you can have idea. Okay. So let us take one example how the spectral terms or features will be determined using LS coupling scheme. আগে দেখলাম আমরা কি যে all L will couple together and results a capital L having more than one value. Similarly, all S will interact, resulting a capital S having more than one value. Then all capital S and L will interact. So now see, due to these interactions, how terms are affected. So, sorry. So let us consider first simple case. Okay, so there will be two systems. Okay, one is non-equivalent systems and another is equivalent systems. So we have to analyze these two systems separately. This is because for non-equivalent systems, we know for equivalent system N and L are same. And for according to Pauli's exclusion principle, N, L, ML, MS cannot be same. So if you are applying your LS coupling scheme in equivalent electron systems, so always you have to be careful so that your Pauli's exclusion principle should not be violated. But in non-equivalent systems, if you are having 2-3 electrons in a where N and L values are different, then you should not bother about your Pauli's exclusion principle because ML, MS can have same values because already your N and L either both or anyone is different because this is your non-equivalent. Okay, so we will study first non-equivalent system, then we will proceed to equivalent system. So let us see atoms with one optically active electrons. For example, hydrogen-like systems. In that case, electron is 1s. 1s means 1s1. So s is equal to half, L is equal to 0. So capital S is equal to again half. So multiplicity 2, capital L is equal to 0. Because for S, this is 0, S state. So J is equal to L plus S means half plus 0 or half minus 0 and half. So you will have your term twice S plus 1 Lj, twice S plus 1 Lj. This is your spectroscopic term. This is multiplicity. This is your resultant orbital angular momentum. This is your resultant total angular momentum. So here this is twice S plus 1. That means 2. Because S is equal to half, or S is equal to L is equal to 0 means S state, or J is equal to half, so twice S half. This is your term. Term means collection of level. আগের কেসে আমরা ওই টার্মিনোলজিতে বলেছি যে টার্ম মানে কালেকশন অফ লেভেল। ওকে, এখানে অনেকগুলো লেভেল থাকবে। হ্যাঁ, so hydrogen তার মানে কি, in case of hydrogen atom you have only one electron, so one electron can lie within this term. There are more than one level. In case of each and every level there exists sub level also, so এটা যে কোনো জায়গাতে থাকতে পারে। Now we will see the case of more than one non-equivalent electrons. So let us take an example of two non-equivalent p electrons. Two non-equivalent p electrons means Np or N dash p. Np means N1 or P. So you have two electrons. For one electrons, N value is N, L value is 1. Another value, N value is N dash, L value is 1. So these two electrons, both N and L are not same. So this is non-equivalent electrons. Okay, so you don't need to bother about your Pauli's exclusion principle. Now, study this system. Okay. You can take your pen and paper because this is not given in this book. Okay, so for this example, let's see. So we have two electrons. For these two electrons, small L1 is equal to 1, this one. Similarly, small L2 is equal to again 1 because this is also p electrons. Then small s1 is equal to small s2 is equal to half. That means spin for both the electron is half. Okay. So if you apply Pauli's LS coupling scheme, so according to first criteria, your spin correlation effect, this spin of two electrons, the half will interact and resultant S will have half plus half 1, half minus half 0. So S is equal to 0 and 1. This is due to what? Spin correlation effect. We will have total spin moments with quantum number capital S is equal to 0 and 1. Clear? Then these two L will interact and you will have a resultant capital L whose value will be 1 plus L1 plus L2 to L1 minus L2. L1 plus 1 2 or 1 minus 1 minus 0 in between minus 1 minus একটা 1 মানে এক এক করে কমবে তাহলে L এর ভ্যালু হবে তিনটা একটা হলো this is due to what due to residual electrostatic interactions. You will have capital value of 2 1 capital L 2 1 and 0 and spin correlation effect S is equal to 0 1. Now according to LS coupling scheme, now spin orbital interaction will take place. That means your this L2 will interact with 0 and 1, 1 will interact with 0 and 1, 0 will interact with 0 and 1. Okay. So let us make a table like this. Say L, then S, then J, then your term মানে হচ্ছে twice S plus 1 L J. Okay. হয়ে গেছে? Now what we will do, L 2 1 0. Now 2 will interact with S is equal to 0, S is equal to 1, 1 will interact with 0, S is equal to 0 with 1, 0 will interact with 0, S is equal to 0 and S is equal to 1. Okay. Then according to spin orbital interaction, J due to interaction between L and S, we will have a J where J is equal to L plus S to L minus S. So 2 plus 0 তার মানে 2 আর 2 minus 0 again 2. So only J will have only 2 value, only one value 2. Similarly here 2 plus 1 মানে 3 আর 2 minus 1 মানে 1. So মাঝখানের একটা ভ্যালু হবে 2. তাহলে 3 2 1. Here 1 plus 0 আর 1 minus 0 মানে একই 1. 1 plus 1 এ ইন্টারেকশন করলে 2 1 minus 1 0 তার মানে 2 1 0 0 0 0 0 1 1 এই হলো আমরা তাহলে আমি যে ভ্যালুগুলো পেয়ে গেলাম now twice s plus 1 lj is very simple twice s plus 1 মানে এখান থেকে তাহলে এটা হবে twice s plus 1 মানে হচ্ছে কত 1 আর l is equal to 2 আছে তার মানে হচ্ছে স্টেট হবে d আর j is equal to হচ্ছে 2 তাহলে 1d2 টার্ম হচ্ছে 1d2 এখান থেকে পেলাম আমরা এখান থেকে কি পাইবো আমরা এখানে s is equal to হচ্ছে 1 তাহলে twice s plus 1 মানে 3 l is equal to 2 মানে 3d আর তাহলে 3D একটা হবে 3, 3D2, 3D1 এই similarly here also এখানে s হচ্ছে 0 তার মানে 1, l is equal to 1 মানে p, j কত আছে 1 তাহলে p1 এই। নাও হিয়ার এটা আমি এখানে লিখে সুবিধা হবে, l is equal to হচ্ছে 1 তার মানে হচ্ছে p লেভেল p স্টেট, s is equal to 1 তাহলে 2s plus 1 মানে 3 তাহলে 3p হচ্ছে 2, 3p1 3p0 এই। Now for this one 0 that means s state আর এখানে 1 1s0 আর এটার জন্য again s state আর 1 s equal to 1 মানে 2s plus 1 3 3s 1 এই। How many terms now you got say কতটা হলো 1 2 3 4 5 6 7 8 9 10 you have 10 terms due to, and each term constitute different levels due to interactions between two non-equivalent p levels. Now you can have idea about the statistical weight factor or statistical weight also. That is twice for each and every case. This is equal to twice s plus 1, twice s plus 1. এটা প্রথম যে আমরা টার্মিনোলজি বুঝলাম এখানে আছে twice l plus 1 তার মানে এর অর্থ হচ্ছে ম্যাক্সিমাম কতটা ইলেকট্রন এই টার্মের মধ্যে থাকতে পারে। এটা তুমি twice s plus 1 এটার জন্য যদি করো তাহলে এখানে এটার জন্য twice s plus 1 1 হচ্ছে এখানে 0 তাহলে এখানে 1 আর twice s l plus 1 মানে 2 into 2 4 আর 5 তাহলে এটা হবে 5 তাহলে এটার জন্য এই লাইনের জন্য এটা হচ্ছে 5। সিমিলারলি প্রত্যেকটার এরকম তুমি করতে পারো। পরেরটার যদি করো তুমি তাহলে twice s plus 1 মানে 3 আর twice l plus 1 হচ্ছে 5 তাহলে 3 into 5 মানে 15 এরকম পরেরটারও করতে পারো। এখান থেকে তুমি টোটাল নাম্বার অফ state পাইবে, total number of state তার মানে total number of electrons can be occupied within these terms. Okay, so this is your idea about spectroscopic terms or state when we are analyzing interactions between two optically non-equivalent p electrons. Okay, so now you okay. Now let us take homework. Considering note down, you note down please. Considering LS couplet scheme, find out the spectroscopic term value for the following non-equivalent electrons. For example, এক নম্বর হচ্ছে np n-p যেটা আমরা আজকে করলাম, দুই নম্বর হচ্ছে nd n-d, তিন নম্বর হচ্ছে np nd। তার মানে তিনটা কেস আমরা এক্সাম্পল হিসেবে দিলাম। এক মিনিট। হ্যালো, হ্যাঁ স্যার, হ্যাঁ বলুন। হ্যাঁ হ্যাঁ, আমার তো 9 জন স্যার। হ্যাঁ হ্যাঁ, হ্যাঁ হ্যাঁ হ্যাঁ, ওকে। মনে হয় 4 জন, আমি এক্স্যাক্টলি বলতে পারছি না স্যার, 4 জনই মনে হচ্ছে। হ্যাঁ হ্যাঁ, ও তাহলে 4 জনই, হ্যাঁ 4 জনই। হ্যাঁ 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 হ্যাঁ, আচ্ছা আচ্ছা আচ্ছা, ঠিক আছে, ঠিক আছে স্যার। ওকে, হ্যাঁ, থ্যাংক ইউ। So this is your homework. So next day you, okay. So next day তে তুমি এই আহ, তিনটা, একটা তো আমি করিয়েছি, বাকি দুইটা সিস্টেমে 2 ইলেকট্রন সিস্টেম নন ইকুইভ্যালেন্ট, সেটা করে নিয়ে আইবে। আচ্ছা, নাও আমি এখন একটা হোয়াটসঅ্যাপে একটা ইয়ে পাঠিয়েছি। এক মিনিট। রোটেট করে কি করে এটা বুঝতে পারছি না। এটা তো ওকে। Okay, so Dekho, we have calculated all the terms resulting due to interactions between two uh, p non-equivalent p electrons. সেটা আমরা দেখছি কি কি হয়েছে, 1s0, 1p1, 1d2, এরকম করে করে 3s1, 3p0, এগুলো আমরা দেখছি। তো ইনিশিয়ালি আমরা d2 spin spin correlation, এটা হচ্ছে এনার্জি লেভেল ডায়াগ্রাম corresponding to these interactions. Okay. So প্রথমে আমরা কনসিডার করেছিলাম, ফার্স্ট উই কনসিডার্ড স্পিন স্পিন কোরিলেশন এফেক্ট। According to this, individual spin of two electrons interact with each other and results a spin moments যেখানে s is equal to 1 and 0. Now আমরা according to L coupling scheme theory আমরা দেখছিলাম যে highest s value will lie lowest. So lowest S value will having higher energy. So আমরা S equal to 0 উপরে এটা নিচ্ছি। So 2S corresponds due to these interactions. Okay, and this is unperturbed. Then we considered interactions between electrostatic interactions, that is interactions between L's. So S is equal to 0 wala, দেখো S is equal to 0 wala তার মানে হচ্ছে 2s plus 1 is equal to হচ্ছে 1, তাহলে এখানে আছে তোমার 1s 1p 1d, আর 2s plus 1 is equal to 3 wala দেখো তোমার 3s 3p 3d, and then L plus S ইন্টারেকশনের ফলে এখানে দেখো 1s0 একটা আছে, 1p1 আছে, আমরা যে 10টা ক্যালকুলেশন করেছি এখানে দেখো 1d2 আছে। নাও আউট অফ দিস টার্ম কোনটা উপরে যাবে, যার লোয়েস্ট L ভ্যালু, তাহলে S হচ্ছে লোয়েস্ট, তাহলে সেটা উপরে গেছে, এরপরে p, এরপরে d, ওই যে এখানে উপরে গেছে। এখানে দেখো এরকম, এটার জন্য SPD3 ওয়ালা গেছে এটাতে, কিন্তু 3s আবার ওই L plus S L plus 2L minus S যে উপরে বেস করে এখানে S is equal to 1 L is equal to 1 plus 0 1 minus 0 মানে 1 ছিল, যে তাহলে 3s 1 একটা হইছে। আর এখানে দেখো এই যে 1 plus 1 থেকে 1 minus 1 মানে 210, ওই যে 2 3p1 3p0 3p2, এখানে এরকম 3d3 3d2 3d1. So this part is due to spin orbit interactions. Okay, so this is your spin correlation, this is residual interactions, this is your spin orbit magnetic interactions. Okay, so you analyze the interactions between two optically electrons having configuration Nd and -d, Np and d. Then you draw the energy level diagram. This is your homework for next class. Okay, so today we shall stop here. If you have any query, you can raise, else we will stop. Shubhajyoti?
Yes, sir.
If you have, or any one of you have any query, you can ask, or you can go through. Next day also we can discuss. Okay, so যেগুলো হোমওয়ার্ক দিয়েছি
দিয়ে দিলে স্যার ভালো।
স্যার
হ্যাঁ
হ্যাঁ স্যার, স্যার রেকর্ডিংটা একটু শেয়ার করে দিলে ভালো হয় স্যার।
আচ্ছা আচ্ছা, সেটা করে দেবো। ঠিক আছে, তাহলে তুমি এখন জিজ্ঞেস করতে পারো, অথবা সামনের দিনও জিজ্ঞেস করতে পারো, আর ওই দুইটা পড়বা, ঠিক আছে? নেক্সট ডেতে আমরা মোর দেন 2 ইলেকট্রনস হলে কিরকম হয়, এরপরে ইকুইভ্যালেন্ট ইলেকট্রনে কিরকম হয়, আমরা নেক্সট ডেতে এটা ডিসকাস করব। ওকে, মিস্টার সালাম, ঠিক আছে নি? সালাম তো সঙ্গে সঙ্গে লেফট করে গেল, দেখি রঞ্জিত, Ranjit Tripura, can you hear me?
হ্যাঁ স্যার।
ওকে, সালাম তো বলার সঙ্গে সঙ্গে বেরিয়ে চলে গেল, ঠিক আছে নাকি? তাহলে বন্ধ করে দিচ্ছি তাহলে।
লেফট হয়ে গেছে স্যার।
ওকে, হ্যাঁ ঠিক আছে।